another television experiment tonight. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV experimenters nights. You realise that you do not have to be a radio amateur or TV equipment to participate anywhere in the world. We stream the DATV experimenters nights to the internet, courtesy of the British Amateur Television Club. The BATC site address is batc.tv, and head to the members stream, look for VK7 OTC. You can also receive the DATV signal in Hobart. If you can see the Queen's Domain, you'll be able to pick up the signal. The digital television frequency is 446.5 MHz and is a standard DVB-T broadcast, which means that many standard and high-definition set-top boxes and digital televisions may be able to tune to the broadcast. A directional antenna pointed toward the domain and a set-top box or TV that can tune 446.5 MHz is all you need. You can also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV experimenters night. We just had a bit of a blast from the past there. I unfortunately forgot to bring the my USB key that had the up-to-date introduction, so I happen to have a USB key with an old introduction on it. So I'll just clarify that it's not the BATC streaming site, it's actually the YouTube streaming site. And if you head off to reese.asn.au and head to the events, pull down news and events, you can see the live stream part of that particular menu, and you'll be able to grab see the live stream there on the page. So so apologies for our slight blast from the past there. So okay, we've got a pretty full night tonight, and I've got some very interesting show and tell and some people coming into the studio as we go through. So now, I wanted to start off tonight with a update. The end-fed half-wave antenna that we did a bit of a feature on last week with Ben, VK7BEN, using Ben's end-fed half-wave kit, which is what I'm showing here, the matching transformer for that particular kit. I've been doing some experiments with it, and I've got some results to show people. Now, if we head across to here and we go wide on this one, so on the weekend I was playing with both the variable capacitor and also the counterpoise to see what effect the counterpoise actually had. Now, can I just I'm going to zoom in here on the connections for the variable capacitor, because the connections that I had on here last week that we actually showed had this connection and this connection as the ones that I'd actually connected to the output socket, and also this one went to ground. Now, when I had a closer look at this, because I was getting some strange results, and I realised that this particular capacitor, which is out of a transistor radio, has two sets of variable capacitor plates and the center connection here is actually ground, and then there is one set of plates to this connection, and then one set of plates from ground to this connection, and so so connecting this one and this one together basically was capacitively coupling the two sets of plates within the device. So what I've actually done here is made it so that it's connected to ground and also the one side of the plates, and surprise surprise, everything seemed to come right. The other thing I actually did was make up a little makeshift knob on the front, because one of the things about the shaft is it's actually connected to some of the plates, and so your fingers actually contribute to the capacitance. So there's a little, and I also put a little pointer on here so that I can point to, and you'll see here that there is a, if I do, that's it. This is a 15 and 20 meter, and then around here to the other side is the 20 meter, and the 40 meter doesn't really matter. So anyway, that's my first, I suppose you could say, my confession, because the original connection was giving me some fairly weird results. So what I did on the weekend was have a bit of a play with a counterpoise, and one of the reasons why I put this particular banana plug on here is so that I could bring the earth side of this out so that I could connect a counterpoise to it, because in the configuration that I use with the IC705, the little bit of coax that goes from the transceiver to this particular connection is only about 200 mil long. So a 200 mil counterpoise has very very little effect on the results. So I did actually want to actually connect a real counterpoise on here. So the counterpoise that I actually used, and you can see here, I've got the results across the bands here without a counterpoise, so without anything, just using the coax to the transceiver. You end up with an SWR reading of at 10 meters 2.38, 15 1.66, 20 meters 1.24, and 40 meters 1.38. Now I suppose the 40, 20 and the 15 are actually in an acceptable range. The issue here is the 10 meter. If I put in out a quarter wave counterpoise. Now bear in mind this is a NFET half wave, so this is half the length of the actual wire that you've got in the air, and it's on 10 meters it was actually worse. It actually made it worse. On 15 meters it was a little bit worse. On 20 meters it was a bit better, and on 40 meters it was certainly worse. If I then rolled out a complete half wave counterpoise, so the same length as the radiating element, the SWR on 10 meters came down a little bit. 15 meters came down to vaguely acceptable. 20 meters it was as good as you're going to get. And then 40 meters it was about the same, a little bit worse but about the same. So that's a little bit around putting a counterpoise out. One of the interesting things though that I found, and these are pictures from the Nano VNA, without the counterpoise you've got your 7 meg, 14, 21, 28, and you can see that the 40 meter and the 40 meter and the 20 meter, these are acceptable. These are certainly acceptable. Quite sharp though, and quite sharp down the low end of each of those bands. When you put the counterpoise on, it's quite interesting, because what you get is at about 4 megs, you actually get a bit of a dip here, well and truly unacceptable for an SWR point of view. Your 40 meter is about the same, if not a little bit worse, which is what's borne out with the results. The 20 meter is certainly acceptable. The 15 meter and then the 10 meter don't really change that much, which is borne out in the results as well. So what I then started to do was play with the variable capacitor and see what sort of effect, because I left the variable capacitor at one end, at the low end, so the low capacitance end of its scale. When I started playing with it, you can see, and it had the most effect up in the 15 and 10 meter area. You can see the variable capacitor effect, and here the bottom one here is where it's at. The top one is where it's at its least capacitance, and then as you feed in some of that capacitance, increase that capacitance, so it's the capacitance across the secondary of that transformer. What you start to see is you can see the 15 meter one here is reasonably low SWR. But the 10 meter, forget it. This is just disappeared off the scale. Whereas as you feed in some capacitance, and we're about two thirds full scale to the end of the so maximum capacitance, you actually find that both the 15 meter and the 10 meter SWR actually comes down to almost acceptable levels. So you can get the SWR right down on the 15 and the 20 meter bands. For the 40 and the 20, not that much difference, and it doesn't change this 4 meg, this almost 80 meter dip here. It doesn't actually change that at all. Down the low end, it doesn't seem to have that much of an effect, which is what you'd expect. So anyway, that's the experiments thus far with an end-fed half wave, and I have to admit I'm still very impressed with this little antenna. The fact that I haven't really done that much. I certainly haven't tuned the radiating wire, which I think's amazing, Ben. Now, Ben, I don't know whether you want to make a comment. I haven't got the chat. Oh, hang on. I'll just get the chat channel up. Now, what we're looking at on the screen here, I mentioned to Ben a little while ago that I remember catching up with somebody up at one of the Miena Hamfests, and it was an American amateur who came along to the Hamfest, happened to be in the state, and he brought along. We were doing the SOTA talk, and he brought along his SOTA rig, which I found was absolutely fantastic. Now I have got the streaming channel up now, so the actual chat channel. So I will studio. So you're quite welcome to call in on the chat channel. We also have repeater 2 146-700 and also DMR channel 3807 live here in the studio as well. So if you want to call in on any of those. So what you're looking at here is this is John K1JD, who was at the 2006 Hamfest, and he's got a wonderful little winder here. He used Teflon coated wire. Multi-strand wire. You can see he comes off. The wire comes off here. Is all shielded, heat shrinked. Then you'll notice here this is his 64:1 transform for his end fed. Now these little things here. This was a trapped end fed, so multi-band trapped end fed, and I've got. Oh, that's another picture. I've got a close-up. Here we go. A close-up of one of these little traps, and he uses a toroid, which is wound with wire to get him his relevant inductance at the particular frequency that he wants. Here's another one. It's on a little bit of matrix board. and the Teflon, he actually uses the holes in the matrix board as a bit of a strain relief, which is fantastic, and all wound around this antenna, this fishing winder. And he's got a whole lot of string on here, as well as this Teflon wire. So this was back in 2006, and John K1JD absolutely swore by this little end-fed half-wave antenna, and you can see he was using a 64:1 transformer, matching transformer here, which I think he described this as this was a toroid wound in a very similar arrangement to our matching transformer in Ben's kit. So just phenomenal. Who you come across at a Hamfest, and who happens to be in the state and who's using an end-fed half-wave antenna. Now there's a bit more experimentation to do on this particular antenna, so certainly watch this space. Now the next thing I just want to show you is we have a sponsor child in Indonesia that we sponsor through World Vision, and I got a report from the sponsor child the other day, and I'm always interested in the stamps that come on these letters, and you can see this is two stamps from Indonesia, but the Indonesian stamp, the one on the left stood out for me because it's Arari, which is the Indonesian National Amateur Radio Organisation, and they have a 5,000 rupee, I think, in 5,000 rupee or baht, one or the other, stamp in which is celebrating the 50th anniversary of Arari, and you can see there is a scout there with a handheld, and a very stylised stamp with the Arari antenna and earth symbol. So I just thought, well, there you go. I'm not sure whether they knew that I was an amateur or not, but it was an Arari stamp on the envelope that I got. So I thought that was pretty special. So I thought I'd show that to you. Okay. Now, last week we had Ron Cullen come in and show us his LED monitor conversion to make up lighting panels, and he was using it for the skylight. And I think I showed I had a panel that I'd extracted from a monitor that didn't work anymore. It had two little compact fluorescent tubes in the top and the bottom, and one was broken in both the top and the bottom, and this particular monitor didn't work anymore. So I spent the time. Ron very kindly gave me a couple of links of the LED strips. They're quite thin, 5mm wide strips, so they fit. Oh, very good. And Anthony on the chat channel says maybe he wants you to sponsor him a Baofeng. Well, you never know. So I'll see whether they want to become an amateur radio operator. But very good, Anthony. So I basically mounted these strips. Now, just let me grab the LED panel. So sorry about that. Big bang for people online. I'll just unfurl the power. So before I plug that in, because it's going to absolutely flood the iris on these cameras. This is the panel. You can see I left the surround on there, and all I've done is cut a bit of a slot at the end. There is a wire that goes to the LED strip in the top and the LED strip in the bottom, and you'll actually see, I think you might be able to see the actual LEDs. I've left the lenses in there, so the lenticular lens that's in there that spreads the light out, and so the big test, we'll plug it in, and I suspect everything's going to go dark because the irises on these lenses are going to shut down. Oh no, maybe not. I'll get if I do that, and you can see there. Actually, you can see there the LED strips at the top and the bottom. You can see how many. It's quite dense, the LEDs on that particular panel. It is a really bright panel, and we're actually thinking about potentially putting a couple of these in the studio to replace our trifrost fluoros, and see how we go. And you can also you can, with some of those LED strips, adjust the color temperature so that you can soften the light or make it harder or different colors. Give people a surprise pink glow to their skin, which is what they do in theatres, with a number 47 gel from my theatre days. So that's a bit scary, isn't it? I don't even know whether they put gel in things these days because they're all LED lighting. But anyway, that's the panel, and you can. That's actually quite a good effect. That. So that's the panel thus far. Now I understand that Ron's actually mounted his in the as a skylight, and he's got it solar run from a solar panel, and so when the sun's out, of course the solar panel then has sun on it, provides the current for the LEDs inside. So it lights the dark hallway. So there you go. So update on the LED panels. Hello, Warren. there is a seat in here, and I need Paul in here now. It's Paul. So I'll get Paul into the studio, and a semi-regular contributor, Mr. Paul Pruss. Good evening, Paul.
Good evening. How are you going?
Very well, very well. And this is Mr. FPCL. Now, are you thinking of changing your call sign to a 3-letter call sign? Just as a bit of a off-the-cuff sort of.
I had thought about it, but then I'm a bit of a keep my head down kind of guy, and there seems to be a lot of fluff, a lot of chatting and
a lot of delays.
But and the delays about the whole thing. And I thought, no, I'm not too fussed about it at the moment. I might keep the old ways going and change it when I get my standard.
Okay.
It'll give me something to shoot for.
When will that be?
Oh well, I had been well on the track until until we brought a new child into the house.
Four-legged child.
Yes.
Four-legged fur child.
And trying to study when it's morning time, play with me, feed me is going on has not been too successful as of late.
Right.
So there's about 9 weeks delay on that. I think I have to contact the prep app provider.
That'll be Radio and Electronic School?
Yeah, for an extension.
Okay.
But yes, definitely.
Excellent.
It is on the go. Goodness, it's only been 2 years. I've only been a FCall for 2 years.
And taken out numerous awards.
Numerous. What was the second one?
You're working on that.
Yes.
So, Paul brought along an interesting box this evening.
Yes.
Give us a bit of the story about the box.
Well, for some bizarre reason, after mastering all things amateur radio, I decided I need a new frontier, and I got interested in valve technology.
Woo-hoo!
And I got interested in, originally it was just repairing, wanted some old valve radios.
Okay.
And so I went into a local antique store. I probably shouldn't say that he's going to be flooded now, but and I asked for, did he have any old radios? And he had a few things there for me, and I said keep an eye out. And so I went back in 3 weeks later, just recently, and 3 or 4 weeks later, and he said no, I didn't have anything else, but from the same crowd that we got the stuff you bought last time, there were these things, and it was just the rest of it, and you can have these, no charge. And I was amazed. And what he handed me was some radio valves, some
impressive radio valves.
And I know there's nothing you can practically do with them, but to me they're just strikingly beautiful.
And they're just next to you.
And I'll bring them up. And I'll bring them up. So now I know nothing about these. I have looked them up. Justin will know how to describe them.
No. Well, I might get Alan K1JD into the studio as well.
Oh,
and they are just, I think they're gorgeous.
Oh my goodness.
So we've got, now the first thing that jumps out at me is the size of the filament pins on this, which must be tens if not hundreds of amps. And I think if I'm right on here,
I think you said it was
an 833. No, I don't think it isn't actually an 833. They look slightly different. Maybe it's a 5689. I don't know. But anyway, these are the sort of valves that they use as the exciters for the big valves. So the 10 or 20 kilowatt valves that they used to run for the radio stations, etc. This would be the exciter valve for it. So just absolutely scary, but a thing of beauty.
Oh yes.
That is absolutely stunning,
isn't it?
And your idea of sort of mounting it with a warm blue glow or something.
I was thinking LEDs. Larry Hauer mentioned that what people were doing was applying voltage to the heater in there, and then I looked these up, and it's like 200 VAC, and I think I'll just stick with LEDs coming through the glass underneath.
You need your power supply of a couple of hundred amps.
Yeah. Just I'll use the house. But that's not all.
But wait, there's more.
I'll titillate a little bit with this one.
Okay.
I'll
hand that to you.
Yes.
Well, you can put it there. It won't roll. It won't roll because it'll stop there. So this is slightly smaller. This is a QB3/300 Phillips valve. Now I don't know what the characteristics of this is without taking it without looking it up, but I suggest this is at least a couple of 100 watts, whereas you're looking at a couple of 1,000 watts there. And this is quite a recent tube.
Right.
This is this would be a 1960s,
what would you call that? That would be, we're not talking 20s.
Oh no. That's your 50s and 60s,
yes.
Well and truly. Whereas this would be probably later than that, 60s, maybe 70s. And potentially, I don't know but it could be a VHF type tube.
I think
high frequency tube. But without looking it up, I don't know. But anyway, that's. But still, a thing of pure beauty.
I don't know with the frosting on the underside of that. I'm not sure how much light will come through, but still.
No, well, that'll give a diffused blue light, and that little panel down the bottom is not going to work in your favour either.
No. But we have others here.
Okay.
This.
Now
yes.
I do know what this is, because this is a solid state rectifier that that actually replaces a valve rectifier.
Ah.
So because of the 4-pin, the standard 4-pin, and you've got two pins which are large and 2 pins which are small, so you can't plug it in wrong. The filament and then the plates. Filament and the screen or the grid, one or the other, and then you've got your plate at the top. But that is an international rectifier solid state valve replacement. Quite high voltage too, actually. So
What was the ID number again of the that one there?
QB3/300.
QB3
/300.
/300. Just
I assume the 300 is probably 300 watts or something like that. I wouldn't be surprised if it's not.
Yeah, it's a tetrode.
Okay.
For use as HF or LF amplifier.
Okay. So not VHF. So does it give a some sort of power rating?
Yeah, we do have a data sheet here. I'm just trying to see if we can quickly get up the power rating. We've got spec sheets here.
Dead air, the advertiser will be cranky.
Yeah. The next route, while Warren's looking that up.
And now this is actually,
But wait, there's more.
this is the prize pair, in my opinion, because we can put 2 of these either side, or one of these either side of each other, and I mean, Warren,
Now, these are, look these up. These are Philips TB4
/250.
Stash 1250.
1250, yes.
1250.
Yeah. So I assume these are
Tetrads as well, I think.
well and truly, and I suspect they're 1250 watts. So they're 1.2 kilowatts.
So yes, I just think they're beautiful.
But even you look at the size of the pins that are on this, the filament would be substantial. Well and truly.
That's a TB4
/1250. And the all of the construction is all ceramic inside. It's very interesting. It's a really high temperature. I suspect they're air cooled. They'd blow air around them, but just magnificent. Absolutely magnificent.
And I would imagine that all the bevels and the tolerances in there would have to be
Pretty reasonable.
pretty reasonable
Yeah,
too.
Yep. This is valve manufacturer, late valve manufacturer. So and they're made in France actually. It's very interesting.
Yeah.
Well, one of them wasn't one made in
Holland.
Yes.
That's where I expected it, because that's where the Philips factory is.
Ah.
But Philips have factories all over the place, and so these come out of France. So very
So
impressive.
these won't, like you said, these won't fit in my AVO
Probably not.
163.
No. I doubt there's a socket for them.
or even an adapter for that matter.
Or back up the truck for the filament supply.
Yeah. Yeah, if you hear a diesel generator going in my...
Just, but absolutely fantastic, and
Yeah.
I just these are things of beauty
They
to
are,
be
they are,
to be
definitely.
kept and wondered upon. So, we get a ooh from Anthony. So, okay, he's impressed, and yeah, definitely Ben. Don't forget to get a photo of those for the Facebook page. So, no problems at all. So yes, I might get Warren to grab a few photos of those before they disappear back in the box. So
Well, at the moment, what comes up is rare NOSNIB Philips triode.
yep, okay,
This tube is perfect for high power single end DHT amplifiers. It's also used in mini industrial RF heating devices.
induction heating devices. Yeah. Okay.
Rare. There might. Let's see what this. If
Rare.
this could fund a a 705.
Well, put them on eBay. They'll probably want to know whether they work or not, which might be a bit of a challenge. You can meter the because there'll be spec sheets, I have no doubt, somewhere. You can certainly meter the filaments to make sure they're okay. But anyway, so I might get Warren to take a few photos before they disappear. For the Facebook page. I'll just drop the antenna down. So we'll.
Did you just want to? Do you want this one up in there?
Definitely. Definitely.
Okay. Where's the camera? Camera's right here.
Yep.
Let's make sure we're focusing on those nice valves here. Excellent.
Cool. Fantastic. So, very impressive, Paul.
I was quite fortunate.
And thank you for sharing them.
Oh, that's all right.
I still can't get over the size of the filaments on those. Just scary. Absolutely scary.
I think we need to get Alan in here.
Yeah.
Easy.
Well, I brought him up at lunchtime for the
It's a rectifier.
Wednesday afternoon group.
No,
And,
that's not a rectifier.
Yeah, what is it?
No.
Where's the filament?
Filaments here is the bottom.
Yeah.
Could be. Could be a rectifier tube.
What was
Because
the
you
number on
don't.
that one?
No, there isn't a number. It's
Well,
been
there
wiped.
is. It's just
Oh,
worn
there is.
away.
It's been
Because
wiped
if-
off.
Yeah, because if he wouldn't stick a big thing like that on the grid.
Well, there's one thing to
Yeah.
do. We can
You're
always
right.
we can take a photo of it and put it into Google search for photos.
And see what it comes up
Yeah.
with. Because there's penciled on the base is a 5-689, but that could be a date. It could be anything. It's just
Yeah, there's just
You
not enough
just
there.
can't.
Thickness of the glass. Now that really is a piece of beauty.
no. Do that and see what it comes up with.
I'll go and do it now.
Just
Can you see a grid inside it, or is it just?
well, yeah, I'm not sure whether that's the filament or it's actually a grid. See, look in the top. You can see they come through, and then they've got little springs that I
Yes.
assume they're spring loaded, so that keeps them taut.
Yes.
But on the either side of those wires, there is another grid assembly,
Yes.
and I don't know whether that's like a screen around the filament or what it is. I don't actually know.
I mean,
Anyway,
that's not really helping. And we're wasting airtime.
no, that's all right.
So,
So thank you, Paul.
not a
That
problem.
was phenomenal, and there's a lot of people out there going ooh ah ooh ah ooh ah ah.
Well,
So eBay suggests that antique dealers possibly shouldn't have given them away, says Ben. So I think you ended up with a very good find.
I
there,
hear he's out of
Paul.
business now, so
I love it. Thank you.
thank you.
Thank you. So the next, we might move to the Vhf Uhf List in Australia. Somebody posted a very interesting article by Glenn Robb, who is KS4VA from the US. This was presented to the VHF Super Conference in 2019, and it was a paper around 3D printing of horns, microwave horns. And I thought, ooh, okay. So I printed this particular article out because there was some very interesting stuff in this particular paper, and you can see there that's a 3D printer, quite a large frame 3D printer, and there is a large horn that they have actually printed using the plastic filament. Now, the interesting thing is they have tried printing all the way from K-band through to S-band and above, so all the way from 2 gigs to 40 gig horns. They have printed all of those bands horns. The key thing here is they then talk about in this particular paper about how they then coated the horns, because of course the plastic's not conductive, although you can buy conductive filament. However, the conductive filament is, they make comment in the article that the conductive filament is not that conductive because of course they still need quite a lot of plastic to get it to flow in the 3D printer. So they've got a couple of options here. There is obviously the filament, which they've proved isn't a good way of going. They could cover it with foil, in some sort of foil, aluminium foil, gold foil, some sort of foil. They could electroless plate it, so they can actually plate it using a sort of a plating technique, the plastic, or conductive paint. Now, the conductive paint is the direction they went, and there's a whole lot of options. You can see this is the nickel coating, a paint coating, and this is the silver copper paint coating, and you can see they've printed a whole range from the low microwave all the way up to the high microwave. They experimented a little bit with that coating, and they ended up finding, and here's a good picture here. You can see when it 3D prints, it actually, you end up with quite a rough surface, because and you can see the lines in that particular picture on the left hand side. That the left hand side is the unprocessed, so basically freshly printed, nothing's been done to it, and then they coat it, and then the other side is where they have smoothed those particular corrugations or roughness out using a range of they've used sanding, they've used filing, they've tried solvents like acetone to actually smooth it all out so it just melts the surface of the horn. They've used one of the agents that they used is dichloromethane, which is actually quite dangerous. They talk about the very effective but quite dangerous, and obviously you need masks and need to do it outside and all sorts of things. But they suggest that smoothing technique is a good way of going. Then you coat it with the conductive, and the anechoic chamber. This particular person who wrote this article works for a company that produces antennas, and they have a test range and a test chamber that they can do all this in. So what they did was go through, try it with the unsmoothed. They weren't getting very good results with the unsmoothed. They smoothed it off. They were getting much better results. The other technique they use to smooth it off is, and this is a technique that a lot of 3D printing organisations use, is they have a epoxy resin coating that they actually put over the top of whatever they print, and what that epoxy resin coating does is fill in all the gaps and make it quite a smooth surface. In all of those techniques, they ended up recommending that it was the silver copper paint, conductive paint, which is both of these are coated with. You can see these are the tests that they actually undertook. This is return loss in dB, and it's from 0 at the very top all the way down to -40 at the bottom. The frequency goes from 8 gigahertz up to 12 gigahertz here. And you can see the red line is the rough 3D printed horn that then has the conductive paint put on it, and then the green line is the smooth 3D printed horn, and you can see the return loss is a whole lot less. There's a bit of a dip at about 8.8 to 9 here, and there's a few dips in here at 11. 11, 11 and a half, 11 and 3/4, etc. But the return loss is a whole lot better for the smoothed horn. So their technique looks good. There's a bit of this is the rig that they use for the chemical smoothing. You can see this is the dichloromethane container, and they use a metal paint tray and gloves, and it needs to be done outside, etc., etc. Lots of comments in the article about chemical safety and protecting yourself. Here's a picture of the epoxy coating that they use. These, you mix these two together. One's the catalyst, one's the resin. You mix them together and then coat it, and you can sort of see here. You end up with quite a shiny surface, so quite a smooth, shiny surface, which you then let dry, and then you actually go through and you coat it with the conductive paint, and you can see this is the conductive paint gaps over the shiny epoxy, and you can see that's almost a metal surface, and that's what they used in the tests. So it's and the proof in the pudding. This is a comparison chart, comparison of the 3D printed horns to commercial metal standard gain horns. So this is the blue line is the metal wave line model 299 that covers 2.6 gigs to 4.4 gigs, and forward gain in dBi. You can see the red line, which is the silver copper paint on the smooth versus the nickel paint on the smooth surface. You can see the silver copper paint almost matches the commercial product. So that's why they ended up with the silver copper paint. It's the best arrangement, and almost matches a commercial horn, which is worth hundreds of dollars to buy, versus what it costs you for the materials and the paint and the process and the time. That's their anechoic chamber that they were testing these horns in. You can see all of the conductive surfaces, uneven surfaces, so that they don't get reflected waves and all sorts of stuff in the chamber. And then a comparison, and I actually included this as the picture for this event on the Facebook page. This is just a bit of a comparison on gain and performance from S-band, which we're down at 2 gigs down this end, and we're up at 40 gigs up this end, for each of the bands and each of the horns that they printed, and very interesting. That it just goes to prove that you can actually print a 3D printed horn, go through a little bit of a smoothing arrangement with the epoxy, then coat it with the silver copper coat paint, and you end up with a comparable microwave horn. So I just thought that's a very interesting little article. It is available on the VHF, UHF, and the microwave mailing lists, and freely available from the VHF Super Conference of 2019. So do a bit of a search on 3D printing microwave antennas, and you'll probably come up with the same article. But well worth a bit of a look if you're into microwave horns, and you don't want to actually fold up the metal horns. So there you go. Now I just thought the latest Low Key magazine lobbed into my letterbox on last week. So Low Key is the journal of the VK QRP Club in Australia. It comes out every 2 months. To be a member of the Low Key, the VK QRP Club, is all of about $15 a year. It is not very much, and great little, very practical magazine. So I just thought I'd go through what's in this year's Low Key. It's my subs. So bit of a editor comments. The president, who is Trevor Quick, VK5 ATQ right at the moment, talks about some of the articles in some of the other magazines, and points out a few of the interesting ones, especially from the other QRP magazines. So he keeps a bit of an eye on them, and the Adelaide Hills Amateur Radio Group, who Trevor's a member of, subscribes to many of those magazines. The VKQRP Club Facebook page by VK2KTJ talks about it and points you in the direction of that VKQRP Club. There is very interesting stuff on there, and also the likes of Peter Parker, VK3YE, is definitely a regular contributor. Club news, the 10-year and the 30-year club, and welcome to new members. And I'll just point out that welcome to new member number 934, which is Tony Delabia, VK7 LTD. So I thought I'd point that out. The QRP Hours 40 metre contest in October. This is Andrew Davis, VK1AD, one of the VK1 Andrews. Everyone I think in VK1's called Andrew, but that's another story. This is on Sunday the 18th of October, and it's the 40 metre runs from 0400 to 0459 UTC for CW and PSK, and then for SSB it's 0500 to 0559 at UTC, and they talk about the recommended frequencies, etc., logs, etc. Now, part 3 of Nick VK7 BEE, who is now VK7 Double Whiskey, or Whiskey. So he's just changed his call sign. This is the 80 metre, simple 80 metre transceiver that was born out of a couple of designs that they've adapted and adopted. So this is the number 3 in that particular series. HACRF1, which is a QRP VHF to UHF SDR transceiver by Terry Dawson, VK2KTJ, and he talks about the HACRF, a very nice little SDR box. El Cheapo battery boxes, which is on the front cover here. Very neat little battery box, using the 12 volt 20 amp hour SLA batteries, or the 7 amp hour SLA batteries, and how to put them together into a quick battery pack that you can carry around, and a few of the details. I do like the handle here. It's a bit of a conduit. Yes, very nice. And he comes out to a T socket, which we still use in Wyson. So all labelled up, and earthing and grounding by Trevor Quick, VK5 ATQ, talking about safety earths, RF earths, static discharge, and antenna system earths. And I thought I'd share. Oh, very good. This is. I don't tell you a solar minimum joke, but it would probably wouldn't be well received. Oh, please. But then, what is love? Baby, don't hurts me. No Morse. Oh, please. So, a few dad jokes in there. So, and James Hannibal, who is KH2SR, finger Morse straight key. So this is absolutely fascinating. This is a little Morse key, basically, that goes around your finger. It with a little Velcro strip around your finger that has a little button on it. That is your Morse key that you actually press with your thumb. So very nice finger Morse, they call it. So finger Morse straight key from James. Member classifieds, Chris's crossword. So Chris VK1CT, which just goes to prove that not everyone in VK1's called Andrew. So he always puts a radio-related crossword in. So thanks, Chris. Club nets and frequencies, application for membership, and then members' email addresses, and the HACRF, which is the accompanying photos, colour photos for the HackRF SDR article that's inside the magazine. So that's a quick thumb through of the latest copy of Low Key. Really worth it if you're into home brewing and QRP. Really worth a bit of a look, and a great little magazine that comes out every 2 months. So there you go. Now, can you just have a look whether Rex is out there for me?
We'll see if Rex is there.
Just give him. We'll get an optical update. I'm not sure whether he is or he isn't. I don't know. No? Okay. No. We won't have an optical update tonight, unless Richard wants to give us an optical update.
Tricky?
Tricky? You want to give us an optical update? While that's going on, I received... these have been making their way to the internet via a variety of sources, but the John Moore Memorial Field Day certificate arrived in the post for third place. Portable station, single operator phone only, all bands for a 6-hour category with 71 contacts.
Yeah, not tonight.
Not tonight? Okay, that's all right. So anyway, that arrived in the mail. You also get the results printout. So that arrived from the WIA during last week. So thank you very much. Now, just a reminder. We'll finish off with a bit of a reminder. The next Wednesday night is a presentation night for Reist. The presentation is by our very own Steve VK700 Oscar on his obsession with SSTV cams, and also his aluminium PEX aluminium, which is the gas tubing, magnetic loop antennas. So next week up here from 7:30 p.m. Should be a fantastic talk. Steve has actually been running his SSTV cams for in excess of 20 years. He has over 120,000 images that he has captured using his SSTV cam. So, and he's going to show not all 120,000 of those photos, but he's going to show a nice selection of photos. So, and also talk about his obsession with SSTV. So, and it's definitely an obsession. So, should be a fantastic night. And we are streaming that particular presentation, so you can see it here on the YouTube channel next week. So, that's our DATV Experimenters night for tonight. Now, we don't actually have any videos tonight, and I apologise profusely for that, because Moi forgot to pull the USB key out of the computer and bring it with him, so I'll go and flog myself later. But it happens. I've had one of those days at work, so it was just walk out of work, walk home, grab the stuff, come up here. So it was just one of those days. Anyway, so that's it for tonight. We'll retire to the club rooms and have a cup of coffee, and we'll have a bit of a chat there. So thank you to all those people who called in on the chat channel. I'll just put out a quick call on our various channels. This is repeated 2, and this is VK7OTC. Just putting out the call for anyone who'd like to make a comment or a question for our DATV Experimenters night. This is VK7OTC listening. And final call for any further comments or questions for our DATV Experimenters night. No, nothing heard. Okay. We'll try on, and this is VK7OTC, club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters night. I'm just putting the call out for any questions or comments via DMR 3807. Over. I tell you what, that really affects that monitor.
VK7OTC, VK7BN. The broadcaster's obvious, Justin. I was just wondering on the back on those nano VMA photos, what the divisions were for the SWR, whether they were one per division or two per division.
I think they're 2 per division, but don't hold me to that, Ben. I think they're 2 per division, but I'll have to check that over.
No worries. Yeah, well, no doubt we'll catch up with you in a couple of weeks to talk about that. Once again, great broadcast, and we'll catch you in a couple of weeks. CK7B NQ.
Yeah, no problems, Ben. No problems at all. And by our next one, I will have done a bit more experimenting with the kit and done a bit of tuning, and also worked out what the best arrangement for the squid pole and all of that is. So there'll be certainly some more findings in a couple of weeks' time, in a fortnight's time. Thanks, Ben. Cheers. Okay, that's our DATV experimenters night 73. Have a great week, and we'll catch you at the presentation night next week 73.